Bienvenidos al auditorio Mario Lacerna. Al ingresar al auditorio, ubique las salidas de emergencia señalizadas con luz verde. En caso de emergencia, conserve la calma y evacúe con precaución. Le solicitamos el favor de apagar sus teléfonos celulares y les informamos que está prohibido consumir alimentos y bebidas en el auditorio. Gracias.
Hello, can you hear me well? Not very well? Like this? It's fine? Okay, good. Well, so this is the inaugural event, the opening event for the summer school in 2023 that it's done by OPHI, and we are very happy to have both of you talking about poverty here in Colombia with students from all over the world. So this is an amazing event. This is amazing for us as the University of Los Andes to have such a great group of students and of great and experts, professors, like the best two professors that we could have in the topics. So we're going to start with their conference. I first want to present Sabina Alkire. She's the director of the Oxford Poverty and Human Development Initiative at the Oxford University, and she's also a professor of poverty and human development. And Professor James Foster, he's a visiting professor right now at the International Institute of Inequality at the LSE, and he's an economics professor at the George Washington University, and he's a member of OPHI now. And as you might know, and as you have heard from the courses, they started with the measurement of poverty, precisely that we are using here in Colombia, and that it might be used in many of your countries as well. So we are going to hear about a new paper that they have and a new initiative in terms of measurement of poverty. So I give the floor first to. You want to go first? Yeah. Okay, so you go first, Sabine, please. Temporarily.
Thank you so much. I just want to say how lovely it is to be here in Universidad de los Andes, to have the summer school here in a place that has so much experience and insight and research and ongoing innovation on the themes that we're teaching about. So it's really lovely to be here, and I'd like in particular to thank the professor of the university, the president of the university, Professor Raquel Bernal, for hosting us, also the director of the CODS, the Center for SDGs, Professor Juan Camilo Cárdenas. We are so grateful for the association with CODS, and also the Dean of Economics, Professor Marcela Enslava, because of the link with economics and the work that we're doing. And before we begin, I would like in particular to thank two people. One is our commentator and our host at this event, the Professor of Economics, Adriana Camacho. It's really lovely to have you, and we're really looking for this interchange. And I'd also like to thank Dr. Mónica Pinilla, the Deputy Director of CODS, professor in the Faculty of Medicine, and a long-time colleague in OPHI for their leadership of this event. So I have two little things for them before we begin the event. Moni, would you mind coming up here? Thank you so much for your So how James and I have organized this is that James will go first and present a bit of the methodology and then a paper, and then I will give sort of highlights of some empirical work in the last 5 years. Over to you, James.
Got it. Now, no one keeps me down, so I'm going to see if I can walk over here for a second.
Are you to present here so that we move?
Yes. Yeah, we can go down.
Yeah.
Right. I had some new pictures. Well, good to see you here. I hope everyone's enjoying enjoying yourself as we get the technicalities arranged? Everything's fine from my point of view. It's been beautiful since we've been here. Thanks to everyone who's making this occasion so nice. Today's discussion will be on the role of inequality in poverty. So I should probably get to a microphone, you know, that would be nice to do. There it is. Thank you so much. Yes, indeed. And I'll explain that in just a second, but you know, one of the things we did early on with the FGT measures was to include a role for inequality in poverty. The person who made that so important or talked to us about it was, of course, Amartya Sen in his remarkable 76 paper. Now I can continue, can't I? Before then, I want to say happy birthday to someone. Happy birthday, America. All right, continuing onward. Great, so let's see if we can down the lights just a smidgen here so that we can see this a little bit better. Poverty measurement before 1976 entailed really just finding that poverty line. It was the identification of who is poor. Sen then shifted the focus to aggregation. That is, how do you combine all that information together? And then, yes, I usually am so loud, I don't want to overpower people, but if you say so. And how do you then decide whether one aggregation approach is appropriate? That leads to what we call axioms. He proposed a transfer axiom for poverty measurement, which said that if two incomes, right, of one person, a poor person and another poor person, come closer together, so there's less inequality, then poverty should fall. Now, Sen's measure itself had some drawbacks. It was a little unintuitive, it didn't decompose, so then some co-authors and I put together a set of indices that was decomposable, the so-called P-alpha or FGT indices, that remedied some of these shortcomings, but you know, I think it was quite a reasonable group. It had a role for inequality in poverty. Here's the class. The main members are the headcount ratio, which gives you a measure of incidence of poverty, the poverty gap, which gave you a measure of depth, and the squared gap, which gave you a measure of severity. Note that the last measure satisfies the transfer axiom. And in fact, any measure from alpha greater than 1 would satisfy it. And that meant that inequality would affect poverty. The most intuitive, of course, was P2, and it emphasized the poorest of the poor in a very intuitive way. The weight on the gap was a gap. So the larger the gap, the larger the weight, hence emphasizing the poorest of the poor. Applications of these measures included at the World Bank through the poverty reduction strategy papers, in the academic venues. Virtually every paper out there on international poverty included some mention of the FGT indices. Policy with Mexico's targeting of the Progreso program with P2 as given in its law that it had to target on the basis of P2. And empirically, I give the example here of India post-liberalization. And you'll see over on this side that all of India experienced a decrease in poverty according to each of the three measures, headcount, gap, squared gap. And then over here in Maharashtra, we saw indeed, with the first two measures, a decrease, but the final one, which was emphasizing the poorest of the poor, there was some discrepancy. In fact, poverty had gone up over that intervening period, and that alerted people to look at Maharashtra and understand what's going on there. So there is this role for inequality in poverty in many, many ways. Uh-oh, I don't like that. I can't believe I remedied that. I can't believe I turned it off. I can't believe it came back on. Yes, someone is playing games with me. Of course, no problem. Which button do I not press next time? Yes. I can see it perfectly here, folks, but it isn't on that. Is it there? Yay! Okay. So there was back in 97, Amartya Sen and I wrote in a last chapter of the annex on economic inequality that, we really ought to have a multidimensional approach to poverty. That was based on the capability approach. And many years later at a conference, Sabina Alkire came up to me and said, I think what you're doing has some relationship to multidimensional poverty. I said, no, we can't measure multidimensional poverty, it's too hard. And she then said, well, come to Oxford sometime. We talked for 5 hours and the paper was drafted. So that indicates the incredible synergies that went into the work. All right, so the new approach had a novel identification approach, which was a dual cutoff, cutoffs in each dimension, and also kind of an overall cutoff, the number or amount of deprivation overall. And it had a novel aggregation, the adjusted headcount ratio, M0, or what we call the MPI now, measured both the incidence and the intensity of poverty together. The question is, how does inequality enter into this picture? Well, you're chopping into two groups, the poor and the non-poor, so that's a spread. You can see how many there are, etc. That's sort of like inequality in a crude sense. And of course, the MPI can be used in different regions of a country or among different groups of people to see the inequalities between the regions or groups. But actually, as a measure, M0 doesn't really have a sensitivity to inequality, as you might see with the transfer axiom in inequality measures or poverty measures. This paper explores the possibilities for including inequality into the MPI framework. Yes, no longer works. And this doesn't work. No, nothing here even. Great, we're in good shape now. Sorry for the interruptions, folks. It must be some sort of problem with me and technology at this point. So I must have been having it rubbed off a little bit from friends of mine who have problems with technology. All right. So today's talk, if I can get on with it, is a review of uni and multidimensional approaches. We'll talk about the global MPI, Colombia's IPM, but MPI, incorporating how we can incorporate inequality into the multidimensional poverty index approach, MPI approach. There's a new axiom we'll tell you called dimensional transfer. New measures called the M-gamma class of measures, which include the headcount, the M0 measure, and other measures that are sensitive to inequality. Now, there is a cost to adding in sensitivity to inequality, and that is, if you have dimensional transfer, you can't have dimensional breakdown, which is really an important axiom. So we make that clear in a proof, in a theorem, and so we turn to an alternative approach that others have put forward. Tony Shorrocks in particular has been one putting it forward. It's using the Shapley value from game theory to attribute, of a whole, the parts that each dimension here would be contributing. So what is dimension 1 contributing to overall poverty, etc. Shapley value does that very naturally. It's only one way of doing it, so I can't really say it's definitive, but it's a way of doing it. And what's interesting about it is that within our framework, within the M gamma measures, the squared count measure with the 2 attached, like the squared gap measure, has a perfect formula for breakdown. It's not a dimensional breakdown. It's a little bit different because it includes data from other dimensions in dimension J's component, but it's at least a way of linking overall poverty with inequality to something that can be attributed to the dimensions. We'll have an illustration from Cameroon. All right, so 2 existing technologies exist for the coexisting technologies for evaluating poverty. One, unidimensional, when you have a single variable like calories or income, which can be used for basing your analysis on, or when variables might be meaningfully combined, expenditure on different things, into one overall expenditure variable. And then there's multidimensional, which is when you really can't easily convert different things into one overall welfare indicator. Or you really don't want to, because your policy is wanting to find out something different about, let's say, food and non-food consumption. So you can aggregate that, but it also might be important from policy to leave it disaggregated. Both follow the 2-step procedure of Amartya Sen: identification, who is poor, which allows targeting and so forth, and aggregation, how much poverty is there, which allows you to evaluate and to monitor poverty through time or see the impact on poverty of different things happening. In unidimensional poverty analysis, the identification step is usually done with a poverty line, Z, or in this case, pi. So this is a numerical amount of income, or whatever it is you're measuring, below which you're considered to be poor. Aggregation step is done with a poverty measure, indicated here by a P of X given pi. The formula takes all the different data and combines it into a level of poverty, P of X given pi. So with the FGT measures, it's pretty straightforward. Let's do it quickly for one example. All right, we have income 7148, poverty line 5. Deprivation vector tells you who is poor given that poverty line in that distribution. You can see the first one is not, so you get a 0. The second one is, the third one is, and the fourth one is not. So 0, 1, 1, 0 is the deprivation vector. Take the mean of that vector, and guess what? That will give you the percentage of the population who's poor, the headcount ratio. But we might want to look at depth too. So instead of looking at the deprivation vector, we could look at a normalized gap vector. Normalized gap, here's the poverty line, here's the income, somewhere between 0 and the poverty line, let's say, if you're poor. Okay, what percentage is the gap of the poverty line? 50%? All right, you line up all those normalized gaps for each person, with the non-poor people having 0 gaps, of course. And then you take the average. Let's see what we get here. Normalized gap vector, we have 1 as the first income, 5 minus 1 is 4 over 5. 4 over 5 right here, that's the second person. Of course, the first person is not poor, so 0. Third person has an income of 4, therefore 5 minus 4, gap of 1, 1/5 is the normalized gap. and 0. Take the mean of that matrix, zoom, you have the poverty gap measure. So the mean of that vector, poverty gap. Now, let's suppose that we wanted to emphasize the people who are really poor. We'd square the gap. The people with big gaps would still have fairly big gaps. Those with small gaps would have them disappear, get much smaller. So let's do that. Take a square of 4/5 and 1/5. 0, obviously, net 0. But what's cool here is the ratio of the poorest person's data to the next poorest person's data is 4:1. But over here, where you square it, 16:1. Who matters more? So it's the poorest of the poor. Take the squared gap. Now you take the average, and you get the squared gap measure. 17/100 for this example. That's the FGT2 measure. All right, all of them are based on the normalized gap. You can see that. The first one is based on a normalized gap to the power 0, but the rest have powers of 1, 2. And the headcount ratio, unfortunately, is the most common. But we're trying our best to get people to look at depth and severity a little bit more. Now, multidimensional. Bang, in your face. We have a matrix of data. What are we going to do with this matrix of data? The matrix has, well, say in the first column, income in dollars per day. Second, say years of schooling. Third, maybe self-reported health, with 5 being the best, excellent, 1 being poor. And then finally, access to some social service. How do we aggregate? How do we identify? What do we do here to measure poverty? Here's what we did. We set up the cutoffs. Now, cutoffs were naturally, in this environment, pretty simple, because you could say $13 a day is roughly what the US poverty line would net. Not perfect, but it's close to it. Everyone would argue that having a high school education is crucial in the US, so therefore 12 as a sort of minimum. If you're below 12, you're considered to be poor or deprived in this dimension. Now that we have many dimensions, we use the term deprived for each dimension. The next one is a 3rd level on the 5-level indicator for health. It is corresponding to good health. If you're below good health, so you're fair or poor, you're considered to be deprived. And if you don't have access, in other words, you're not 1, but something below, the only thing below is 0, you don't have access to the social service, you're considered deprived. You can see that then. That cutoff gives you already some insight, but it doesn't tell you who's poor. First off, let's take that data that we've done just a second ago. Notice how I've underlined the people who are deprived in, their dimensions. And take the ones with the underlines, put 1s there, 0s for the rest, and you have a simple deprivation matrix. That simple deprivation just has 0s and 1s. We're doing a case where we're not weighting anything more or less. We're considering all dimensions the same to make it easy to understand. And then look, some of them have 0 as the share of deprivation score. That's person 1. Person 4 has 1/4. Person 3 has 4 out of the 4. Person 2 has 2 out of the 4. Who's poor, who's not? That's what the question is. We have 2 that are pretty clear, but the others, who knows? So in order to figure out who's poor, we set a second cutoff. The first type of cutoff, so deprivation cutoff, is a poverty cutoff. We set that, and say it was 2/4 was your poverty cutoff. Then all of those with 2/4 or more are considered to be poor. Well, that includes the 2 middle people. With the 2 middle people being poor, we can immediately tell you that there's 50% of the population is poor. Headcount ratio. That's not really good enough, though. So here's what we do first. We take and censor the data and say, look, if you're not poor, I'm sorry, I'm not going to consider your deprivations because, frankly, you're not poor. Let the Ministry of Education deal with your deprivation, not the Ministry of Social Development. Okay, that's why we censor what's going on to get this new censored matrix. We also censor the counts. And then we average up the counts, the scores, or we take an average of the matrix. If you look at the matrix first, the average of the matrix is 6 over 16. 6 over 16, 3/8. A second way is to go over to the right and take a look at all of the numbers there. There's 4 of them, add them up. We get 6 over 4, divide by 4, 6 over 16 again, 3/8. 2 ways of expressing the same thing. There's another way, which is take the headcount ratio, 1/2, and realize that if you take the average of the 2 poor people, we get a 3 over 4. Multiply those 2 together, you get 3/8 again. Another way of expressing this inequality, H times A analogous to the H times I of the poverty gap. This is easily generalized to any weights. Now, first of all, the measure that we've just put together, the M0 on the left, the MPI measure, it satisfies what we call dimensional monotonicity, by which I mean that if someone is already poor and they're not deprived in, say, the first dimension, and they become deprived in the first dimension, then the poverty measure should represent that, should actually go up, because there's more poverty overall in society. M0 satisfies it, but the headcount ratio does not. So like the poverty gap being monotonic, it is a similar thing, sensitivity to what really constitutes poverty. It uses ordinal data. Remember, I had the 1, 2, 3, 4, 5 for self-reported health. I could have used 297, 352, any scale, and you still would have had the cutoff, say at the same 1, 2, 3, the third number, whatever it was, everything below it, the entire number that you would get for M0 would be identical. So you don't need to worry about the actual scale attached to the variable. No cardinality, no need for it. Ordinality is enough. Finally, it gives you poverty as, a concept, poverty as being multiply deprived. Properties satisfied, I won't tell you what these all mean. I'll just mention a few of them. Ordinality is being able to be used with ordinal data. We'll talk about that a little bit more precisely in a second. Dimensional breakdown, which means you can take the entire M0 and attribute different parts to different dimensions. Okay? Those are the 2 really important axioms here. The other ones we'll talk about: dimensional monotonicity, I just mentioned to you, and subgroup decomposability, I mentioned to you as well. Looking at poverty by different groups allows you to you can recombine to get the poverty for all the groups, or decompose it again to the separate groups. There's a relationship. Okay, I want to just make sure the definitions of ordinality and dimensional breakdown come through. So I'll just quickly tell you what they are. An equivalent representation is like a rescaling of those health numbers. I just rescale it so that they still are ordinally the same way, but different numbers. Ordinality requires that any equivalent representation should leave poverty unchanged. So even if I use 1 to 5 or 7 to 23, they should all yield the same, in fact, identical value of poverty. By the way, measures that rely on the scale or measure depth have problems with this, because that depth relies on the scale. So you can't have measures that are depth downward, but breadth across. Secondly, dimensional breakdown. After identification has taken place, notice, after identification has taken place, and the poverty status of each person has been fixed, multidimensional poverty can be expressed as a weighted sum of dimensional components. Now, what do I mean by dimensional components? These are components that depend only on dimension J information. They don't depend across dimensions at all. So it's very easy to see, oh, this is dimension J, here's how it impacts overall poverty. The specific breakdown formula for the M0 measure, for MPI, is given by M0 is equal to weighted sum of HJ. Now, what is HJ? It's the censored headcount ratio, which is the percentage of the overall population, which is both poor and deprived in dimension J. Think of that. Both poor and deprived in dimension J. The weights in this case, it'll be equal. No, the weights that we had in the example were equal, and in general, these are the normative weights that you use to construct the measure. Okay, so this formula is really interesting because you can actually look at contributions of dimensions to overall poverty. It's really, really important. Let's look at some of the examples. This is a key example from Cameroon. I'll just throw it at you. You can see the censored headcount ratio, the percentage of populations that are both poor and deprived in that dimension. And then multiply it by the weight to get the sort of dimensional breakdown term. It takes the censored headcount ratio and says, well, wait a minute, but that one's not as important. This one's more important. So you see which one is relatively favored by this. And then finally, you take those terms and divide by the total amount of poverty, M0 poverty, and that tells you the percentage contribution to each of them. After the weights, after the censored headcount ratio, it turns out, well, let's see, child mortality is quite important here. Whereas, well, that was pretty clear from before, it seemed like that would be an important. But then we have other dimensions. Nutrition is important, years of schooling important. Different weights, however, are giving different benefits to one or the other dimension in terms of this formula because you said they were more important or less important. Does this make sense? You could see how you might even budget against this sort of a set of information. Okay. So how is M0 being used? You can't see that, but that's what it says. Global MPI, Colombia, Mexico, women's empowerment in agriculture, Bhutan's gross national happiness, Inter-American Development Bank's Better Jobs Index, the World Bank's Statistical Performance Index, and a lot of them out there that people are working on. Roberto's right here, who worked on the Colombia and now is working on other indices based on a similar technology. So let's just talk about two of those, and I'll try to get through that pretty quickly. All right, so headline for communication means you have a final product that M0, the MPI, tells you here's where poverty is at. And below that, you have the coordinated dashboard, the dashboard of where it is that each of the dimensions is at, where each of the individual components is at, where we had the breakdown, right, just a second ago. That's a dashboard of components. So this is a model for MPIs around the world, and there will be a release very soon in New York of the next year's results. All right, you've seen this a million times. I won't spend a lot of time on it. 10 indicators, 3 dimensions here. Health, education, living standard for the global MPI indicators include nutrition, child mortality with equal weight in that health dimension, years of schooling, school attendance, equal weight, and then several indicators under assets. You can see under living standards, they have equal weights also, 10 minutes. A person is deprived if you're, a person is poor if you're deprived in 33%. Here's the formula you've just seen a second ago. H is incidence, A is the intensity of people's poverty. Here it is all over Africa. You can see the global MPI all over Africa and different regions, belts of extreme poverty going from one country to the other. Decomposability is being used in this graph. In this, we're looking at breakdown as well. Here's breakdown. Each dimension, you're looking separately and saying, well, how is it improving in each dimension? Using the breakdown terms of the censored headcount ratio. Likewise, here you can see different states are changing differently within the country of Nigeria, this is, and That's using both decomposability and breakdown. Okay, in Colombia, coordinating action. So this, there you are, Roberta. This is from the website, you know your own measure. The main thing here is this wonderful picture where people get together and use the breakdown that we've been talking about to say, well, look, your measure, your dimension here is not moving quickly enough. Come on, get on. So it is a coordination technique that is also making individual ministries accountable in ways that no other measure can do. Okay, that is the review. I've just spent a lot of time on the review. That's because I wanted to make sure you knew what was going on. Now let's look at trying to introduce inequality into the MPI framework. M0 isn't sensitive to distribution among the poor, and the reason is that the mean of the deprivation scores is a mean. Doesn't have anything to do with distribution besides the mean. The transfer axiom requires sensitivity to certain types of inequality. Existing transfer axioms that are out there for multidimensional poverty are really not applicable to the measure that we put forth. Some are requiring cardinal variables. Others are just weak. They don't have a strict role for inequality in poverty. And M0 satisfies those weak ones very easily. The question we address here is, can we create a transfer axiom for measures that use ordinal data? Can it go beyond a weak version, giving inequality a greater role? And can appropriate practical measures be constructed, satisfying the axioms of ordinality, dimensional breakdown, and the new transfer axiom? So recall the property, which was dimensional monotonicity I just mentioned. It says that multidimensional poverty should rise if a poor person has an additional deprivation. The new property, dimensional transfer, says multidimensional poverty should fall as a result of a dimensional rearrangement among the poor. A rearrangement among the poor takes a strict dominance between two poor people and mixes it up, thus blunting the sort of positive association between dimensions. Okay, so that is the notion of transfer we're considering here. It's based on Atkinson and Bourguignon's approach. All right, what is a dimensional rearrangement among the poor? I'd rather show it to you than tell it to you, and I've just done the same thing as I did before. Yes, folks. Thank God. So, here we go. It's like this. Let's begin with those cutoffs that we have, and we have a matrix of achievements. (12, 13, 2, 1, 10, 7, 1, 0. Notice that the first person, as opposed to the second person, there's a dominance there. The first person is poor, but has got more of everything than the second. In the second matrix, we have flipped the second column so that 7 becomes 13, 13 becomes 17. Ah, I see. So it blunts the strong correlation, thus making it so that we should have less inequality according to the Atkinson-Bourguignon way of thinking of things. But there's a second problem here. If you do all of that, but you don't change deprivations, our types of measures won't register it. So consequently, we have a second requirement, that the same thing must happen over at the right-hand side in deprivations. Notice we've switched deprivations. One was deprived, the other was not. We switched. Now the deprivations have gone in the other direction. Originally, one was deprived in more things than the other. Now it's switched. When this occurs, inequality falls, and we should have dimensional transfer applying so that poverty should go down. The headcount ratio and the adjusted headcount ratio just violate this axiom. The number of the poor and the total deprivations among the poor are just unchanged by this kind of a transformation. This is a class of measures built on the MPI. We have M gamma 0. It's the mean of the deprivation score vector, where each entry is raised to a power gamma. Okay? So we call it the squared gamma approach. And what we have is each one of these C gamma i's is, in essence, a normalized attainment gap among the poor. And it looks very much like FGT, and like some measures that have been built off of the FGT that I list over here. The main measures are the headcount ratio, the adjusted headcount ratio, and the squared count measure. The squared count measure is quite cool because we're squaring that deprivation score. That's interesting, very similar to FGT2. The axiom satisfied, yes, ordinality. Dimensional transfer satisfied for gamma greater than 1. Uh-oh, but dimensional breakdown is violated for gamma greater than 1. Oops. So this won't work. We haven't been able to succeed in doing anything here because we've got rid of a really important axiom by taking on another one. Are there other measures that might be able to fulfill both at once? And the answer in the next result is no. There's no symmetric multidimensional measure satisfying both dimensional breakdown and dimensional transfer. There's a proof. It's indicated here intuitively what's going on. DT, DB are against each other. Conclusion, it's easy to construct measures that have this sort of inequality and poverty in the multidimensional world, but it's at a cost. Dimensional breakdown has to be lost. All right. Real importance of dimensional breakdown we know. Here I just list a few of them to make sure that you understand. This is important stuff. So is there a resolution? Can we maybe make one of the axioms weaker? No, you really can't. They're both very, very weak. So Dot, in a paper, suggested, why don't you use a Shapley approach? So we thought we would. The pros of Shapley approach is that it can be computed, right? The contributions of each dimension could be computed indeed. It's especially useful when things are nonlinear, like what we have with the M gamma class. And it takes the average marginal contribution of the dimension across all orderings, whether you do the first one first, or the second one first, or the third one first. Shapley averages across all of that in a nice way. The cons of the Shapley approach are quite straightforward. First of all, it's a real pain to calculate, okay? It really is. It's like infinity of things to calculate. And it's unintuitive for policymakers. It's a black box. So you're saying, okay, this happened, this is what it is. How do you know? Well, I did these incredible number of calculations. That's how I know. So, and it's also problematic for hierarchical values, like what we're talking about, these variables here. They're hierarchical with a dimension, and then within them, different indicators. I don't have time to actually go through the individual discussion, but just believe me, that if you have Pat and Joe, and they look pretty similar, there's Pat and there's Joe, but they have dramatically different contributions of the first indicator to overall poverty, except in 2 points. And the 2 points are the original M0, naturally, it's got breakdown. Okay, so you're gonna have that automatically. Shapley breakdown is the same as the dimensional breakdown for that measure. But what was interesting is there's that second measure, the squared count measure. The squared count measure had a nice, right? It worked well in this environment. All the rest of these measures don't. And that's first of all a statement saying don't just use Shapley without thinking, because you might be really getting a wrong contribution of each of the dimensions you're trying to understand. So this inconsistency means that we should focus a bit more on the squared count measure. We do. We then find out that there is indeed a formula by which you can actually determine the Shapley value, closed form formula for the squared count measure. And let me just briefly give you what it is, show you an example, and I'm done. HJ is the censored headcount ratio. AJ is the censored intensity, the group of people that are both poor and deprived in J, what their intensity is not just for J, right? It's across all dimensions. We're going beyond dimensional breakdown here. We're looking at other dimensions. So it's a little unfair, but we're doing it. And then finally, multiply the two together, you get a censored adjusted headcount ratio, kind of the average intensity relative to the entire population. The Shapley breakdown for M2, the squared count measure, can be calculated using the following elementary formula. M2 is going to be equal to the same type of weighted average of now M0J. That's remarkably simple. Look at it compared to the usual dimensional breakdown. Yes, it only has data for the jth dimension in that term Hj, whereas M0J has data from across all dimensions. So that's the difference. Question, does this really change relative contributions of dimensions? Let's take a look at an example. Here's an example from Cameroon. Hj, Wj, Hj as we did before, but now we'll calculate Aj, M0J. And here are the Shapley breakdown terms. We compare it to the original dimensional breakdown right here versus here in terms of the relative contributions. And as you can see, not a lot of difference, but it could be a lot of difference. It just isn't. Okay? Some cases it may be. Yes, we may want to investigate why it's so large in one case or small in the other. But what's interesting is how closely aligned they are, even when you take into account inequality. Even when you take into account inequality. So, here's what I've tried to tell you about in our work. We've defined a strict dimensional transfer axiom that has a strict role for inequality in poverty measurement in the MPI framework. I was explaining to you how it conflicts with dimensional breakdown. It's a great axiom, but it conflicts with the other great axiom that we use all the time. We derived a simple expression for the Shapley breakdown of the squared count measure M20. So in sum, we might recommend looking at these three main M-gamma measures, analogous to the P-alpha measures. The headcount ratio. It's an intuitive partial index. It's not really conclusive in itself. The adjusted headcount ratio, which is pretty darn good with its dimensional breakdown. It's the core measure for looking at what's happening to the poverty in a given country or across different regions. And then finally, look at the squared count measure and its Shapley value, recognizing that it's not a dimensional breakdown, but it can at least give you some insight in evaluating the effects of inequality among the poor. It's this last measure that has a role for inequality in multidimensional poverty analysis. Thank you very much. Any questions? No questions. I'll give it over to you. Oh, they do? Yeah. You got it.
Is that okay?
Works for me.
So there will be a chance for questions, but a little bit later. So James presented one piece of work in depth. And what I'm going to do is just, in a sense, give you a table of contents of some of the empirical work that various colleagues have been doing over the past 4 years, in one case 5 years, just so that you get a sense of the new areas that are moving out. I can't do justice to all of them, as time is very limited, and we do want to keep time for our commentator and for exchange. But basically, what we want to look at are some areas that OPHI people have done work in different directions. So the first is looking at trends over time and estimations. A second is robustness. A third are interlinkages. And then we have the child, the gender, and the household techniques. And then disability, work on vulnerable groups like refugees. And then some other topics that I'll just put slides up like impact evaluation or multidimensional well-being that we won't have time to cover, or environment. But I hope that this gives you a sense, a mapping, a cartography of existing or current research areas. And so both we can see together the gaps, and you can also see together colleagues to work with. It would be a joy to work more with colleagues in Universidad de los Andes. So to begin with, James presented the global MPI, which is one way of applying multidimensional metrics with a particular set of dimensions and indicators in a way that is as comparable as possible over 100 countries. And Ushika Nagaratnam and colleagues revised the global MPI in 2018 to better align with the Sustainable Development Goals. And at that time, of course, there were many different options, and so many were implemented. And so it was an important time to look at robustness, which I'll talk about. But also we wanted to begin to explore trends and to look at how multidimensional poverty changed over time, and to do that not as a one-off academic papers, as we had done previously, but to integrate it into the estimations so that it could be updated annually. And this work, Monica Benilla, Fanny Koveshti, Ushika Nagaratnam, many people at OPHI worked extensively on this. And so now we do have harmonized data, which means that the indicators are the same across 2 periods of time for a country. So for example, if one country doesn't have nutrition for men one year, only for women and children, and the other year it does, then one drops the information that's not present in both surveys. And this enables us to have very rigorous comparisons over time. So to give you one quick example from the global MPI, we look at India and see how the incidence, multidimensional poverty and intensity fell over a 15-year period, with over 415 million people leaving poverty in that period. But we also look at subnational regions, and that graphic is of states, where the states on the right hand are the poorest, and the absolute level of reduction of MPI is vertical. So the bubbles nearest to the bottom are winning the race of poverty reduction. They have the fastest absolute reduction in that period. And so whether it was states, children, castes, religions, the poorest groups had the fastest reduction over that 15-year period and 5-year period. So that kind of study, I think, is a descriptive study, but it could be a set of data that could be used for other kinds of analyses, which is why I wanted to bring it to your attention. And these data are all online. But in looking at these data, we also wanted to investigate some other things. For example, as James mentioned, journalists like incidents, not MPI. It's easier to understand. So is there any value added in looking at MPI? And in a paper with Christian Oldeges and Ushika Nagaratnam, we looked at the shortcomings of the headcount ratio in studying trends over the first 10 years of India's reduction from 2005-06 to 2015-16. And what you see is on the left-hand side, you see the reduction by state of their poverty using the MPI. And you see what I showed you earlier, it's a pro-poorest trend. On the right-hand side, we have the same graphic for the incidence, the headcount ratio. So the poorest states, which are about the same, Bihar, Jharkhand, Uttar Pradesh, Madhya Pradesh, Chhattisgarh, are on the far right. But you notice that the depth is different. It's not a pro-poorest trend. Because in the poorest states, many people had high deprivation scores. And so they came closer to the poverty line, but they didn't pop out of it. Incidence did not change, intensity did. And so that's an observation of what would be lost if journalists only look at the headcount ratio. At the beginning of the pandemic, of course, there was a question of how was the pandemic affecting poverty. And that's a question that Ricardo Nogales, Nicolai Sopa took on with Natalie Quinn. And they basically did a combination of projections, translation modules, and microsimulations to try to predict how far an existing trajectory of poverty reduction estimated forward to 2020 was set back. And this was published in July 2020, so you can see the speed at which this work took. It's pioneering work, and we want to do more and, of course, tune it much more than we could in that time period. But it was done by first using the harmonized data, which we already had by 2020, and then carrying it forward and using a projection, a logistic technique, then simulating scenarios. So if people were poor or vulnerable, simulating additional undernutrition. If people had a child in the household, poor or non-poor, simulating children dropping out of school. And then using that simulation on the year of the data. And then now casting that value with a translation model to be able to predict the simulated shock in 2020. And then rather than quantifying it only in terms of millions of people, which we also did and the World Bank also did, we also looked at the number of years it set poverty reduction back. In the early study, it was 3.1 to 9.9. In the published paper, 3.6 to 9.9. We published that in Social Science and Medicine. But that's an example of work that I think blends different methodologies that could, of course, be taken in different directions that are quite interesting and that we're ourselves interested in expanding and improving. Then a lot of work on multidimensional poverty is data constrained, and so it uses repeated cross-sectional data, not longitudinal data. But we were part with Anne-Catherine Guillot and Maurizio Appaplazza of the NetSilk 3 and NetSilk 2 projects of Eurostat, looking at their metrics using the EU-Silk datasets for Europe. And in the NetSilk 3, we used the longitudinal aspects. And we first replicated at a form of the at-risk of poverty and social exclusion measure of Eurostat, which has 3 dimensions: quasi-joblessness, at risk of monetary poverty, income poverty, actually, and a material deprivation index that our co-author Anne-Catherine Guillot built. And by that measure, in just 4 years, between 2013 and 2017, so not years of the 2008 financial crisis, 25% of the population of Europe were poor at least once during that 4-year period, which was much higher than was anticipated. When we added some other dimensions, then the volatility came down. But I think it's really important to use longitudinal data to scrutinize the volatility of indicators in an MPI, see what kind of seasonality we are being subject to, but also see how often it makes sense to update measures and indicators and learn more about these. And then also, of course, there's a lot more analysis you can do when you have a longitudinal data set with MPI. And so I think, again, offering these data for longitudinal analysis is a key value. So these are a few of the work on trends of different kinds that we're engaged in. I want to say that the trends, for example, of the global MPI would not have been possible without Nicolai Sopa, a colleague who will teach remotely on the summer school, but is not here in person in Bogota. And one of his sole-authored pieces, which has really changed our computational estimational life, has been the MPI-TB, the MPI Toolbox, which is a set of startup programs you can now download with an associated GitLab site for any problems, but also for full documentation. And this enables you to compute any MPI. It doesn't have to be the global MPI, it can be anyone. It can also be other kinds of measures. And it certainly simplifies and it pulls out most of the major statistics that one would wish in a standardized format and much quicker. If your computer is gasping for air, it's something to look into. So I put the link there, and there's also a working paper on our website that'll shortly be published documenting that. And all of course, the MPI stuff is documented, and the data do file and data are online. Another area of work is robustness, which we've talked about, but basically we always want to scrutinize how sensitive our measures are to changes in the poverty line, in the weights, or in external data that we bring in, like population data, or anything else that affects the analysis. So to give the most elementary example, we want to know if two CDFs of a distribution of deprivation scores overlap. So again, in the same paper on India, we did this for India in 2000, over a decade. And you see the two CDFs there of deprivation scores and attainment scores. And to our surprise and pleasure, we found first order dominance. So this is something that you could do with your national MPIs, with your research projects. Just check if by chance you have what kind of relationship the CDFs of the deprivation or attainment scores have. We cut it by rural and urban areas. India still had dominance. Another question was a headline number robust? So all of you will work in trying to have your research have impact or trying to have your statistics meet the media. That year, the headline was going to be 271 million people left poverty in India. So we wanted to know what was wrong with our number before we launched it. Usha Kanagaratnam and the team had estimated 19 additional MPI candidates. So we applied all of them, and we looked in India what number of people left poverty if we looked at the alternative MPIs. And in all but one, it was more in terms of a number. And then we looked at the date of sample collection and the date of the population data because they spanned 2 years, and we played with different population numbers. And every other option but the one we released was higher. So we were able to say that our number was a lower bound of the number of people who left poverty in that decade. These are kind of very basic descriptive tests. Then going to a paper published in Review of Income and Wealth, which has a lot more content than I'm able to present, again with Ricardo Nogales, Usha Kanagaratnam, and Nikolai Supa. We did an extensive robustness analysis, both for a limited and for a full set of parameters of the poverty cutoffs and of the weights. So for example, the revised global MPI from 2018, if you changed any of the poverty cutoffs that in the global, as James said, were 33.33%, but if it was 20%, or if it was 50%, what percentage of pairwise comparisons of countries, considering their standard errors, and this was a distribution of 105 countries, how many of them switched which was poorer than the other, or if they were equal, changed? And 94 to 95% were robust. And then what if we changed the scheme of weights from 1/3, 1/3, 1/3 to having 50% on one dimension and 25% on the other, and then rotating which dimension had 50%? How much would that change, again, this pairwise comparison of countries, considering 95% confidence intervals? And 90% were unchanged for MPI, a bit less for incidence at 88. So those are some basic tests, and some people will be learning those later this week. The paper has also more extensive ones than that. But that paper also piqued our interest, and it's common in research that you get into something and then you find a surprise and you get interested. So in that paper, the surprise were these columns. We were looking at, in a sense, the number of deprivations equally weighted that people experienced if they were deprived in one indicator. So these are graphics for each of the 10 indicators of the global MPI, with nutrition on the upper left, and the one that's circled is electricity. And in the case of electricity, you see that on the far left, it's very, very low, much lower than nutrition on the upper left. And what that means is that only 1% of the people who were deprived in electricity were only deprived in electricity and none of the other 9 indicators. 99% of the people who could not turn on a light when night falls had 1 or more deprivations. And what you can see is usually many more. So that was quite interesting that we took that further in a report on electricity, where we looked, for example, at the conditional probabilities for cooking fuel, housing, and sanitation of people who were already deprived in electricity, and looked at this by regions of the world, etc. But that got us very interested in probing interlinkages further. So in preparation for the 2022 Global MPI report, we wrote what is now a research in progress paper, and will go much further, which was just looking at the interlinkages. So remember James's matrix, and there were rows of zeros and ones for each of the 4 people in the matrix. Now think that there are 10 columns for the global MPI, not 4. But every person has a 0 or a 1 for every indicator. Are you with me? So from that simple matrix of all of the poor people covered, 1.2 billion in 105 countries, one could say, well, how many people are poor and deprived in water and sanitation at the same time? Or cooking fuel and electricity at the same time? So it was 593 million people, thank heavens, who were deprived simultaneously in cooking fuel and electricity. These are simple crosstabs. There are 45 of them for 10 indicators. And so you can see the number of million people who were A, among the multidimensionally poor people, and B, simultaneously deprived in these 2 indicators. And that was done for pairs, it's done for trios, there's over 100 trios. And it gave rise to interest, but we wanted to go further. We wanted to look at all 10 deprivations, which we could do. So you can imagine a data set with all of these zeros and ones, and then you sort it so that everybody with the same deprivation profile, if I'm deprived in nutrition, sanitation, housing, and cooking fuel, then everybody else who's deprived in these 4 indicators with me and nothing else is aligned with me. And that's called a deprivation profile, because it's all 10 indicators. And so what you see there is an upset graph, and on the far right is the most common deprivation profile of the world last year, which was those 4 indicators I just mentioned. And the next most common was to be deprived in all 6 living standard indicators: cooking fuel, water, sanitation, housing, electricity, and assets. So, and then we could overlay those. So for example, the most common, those 4 indicators on the right, if you look at all of the dark red bars that have a red circle in them, everybody in those deprivation profiles were also deprived in this deprivation bundle. So the report showed how if you are trying to roll out a water and sanitation program in sub-Saharan Africa, you have a pretty good chance of guessing that most people deprived in water are deprived in sanitation. But it's not that case in South Asia. And so you could see regional differences, country differences, within country differences in the actual deprivation profiles that poor people experience. That goes beyond dimensional breakdown, but it could be very, very useful for very precise planning when that kind of information is useful. Now, there's a problem with the MPI, which is that for data reasons, it's usually restricted to a household. And you might guess on the OPHI team, we care a lot about children and a lot about gender and inter-household disparities. But why don't we disaggregate by gender? Well, because it is wrong. We've never published it, because it would, in a sense, simply reflect demographics when it comes to gender, as it does when $1.90 is disaggregated by gender, which has been done. But go back to the household surveys we use. If you think of completed years of schooling, that's asked of the household roster, right? School attendance, usually asked of the household roster. So when you build an MPI, you are doing an intra-household aggregation of data to identify everybody in that household as deprived in school attendance, deprived in completed years of schooling. But what if we go back to that information, re-index everybody in the household who is eligible for that indicator, and then reanalyze the indicator? I'll give you examples. I won't take you through the notation. You definitely go to sleep. So last year in the Global MPI, we asked a question. We said, how many people of the 1.2 billion we covered last year do not have an educated girl or woman in their household, anybody aged 10 or above? And by educated, in the Global MPI, we don't mean 12 years. We mean they completed 6 years of schooling. And everybody in that household had a woman who had completed 6 years of schooling, or had a woman or girl who could have completed it. And sorry, this is 2021 data, so it was 1.3 billion people who were poor. I don't know if you want to guess. We were not pleased. We found that 2/3 of the poor people, 836 million people, lived in a household with a girl or woman who could and should have completed 6 years of schooling, but had not completed it. But what did we do actually? We looked at that intra-household data, and we used it to figure out how many people without schooling were women within men, how many households had a girl or woman, but no schooling. So we returned to the microdata and did a second pass at gendered aspects. And we can do that for other indicators of the Global MPI, and with Ushikanagratnam Nikolai Supa, we're doing that extensively for all countries. But particularly we're looking not only at years of schooling, but we're looking at if children are undernourished. Are they boys or girls? For example, in South Asia, across the 7 countries for which we have data, there's no statistically significant difference between undernutrition for girls or boys. And we also find that 72% of children with undernutrition are poor, but a lot of them are not poor. So we have to look at undernutrition among non-poor children as well. We also look at school attendance. Girls or boys in Pakistan, Afghanistan, even India, statistically significantly more girls are out of school than boys. But in Bangladesh, it's reversed. There are more boys out than girls. Interestingly, in Pakistan, 22% of children who are under the age of 5 are undernourished and share their household with another child under 5 who is not undernourished. Similarly, 22% of children who are school-aged are going to school and share their household with another child who is not going to school. So we also look at intra-household disparities. You have to be careful with the data, with your number of unweighted samples, demographics. It matters a lot to get the details right. But the techniques are there. We also look at something called pioneer children, which is a child who lives in a household where no adult has completed 6 years of schooling, but that child has. In South Asia, 436 million people live in households without an educated adult, but 1 in 4 of them have an educated child. So that's a little bit on the gendered and poverty, and that's really all that I have time for. So I'll just sort of flip through some slides on other things. With Jacob Dirksen, we surveyed different ways we've been incorporating data on children into measures. And even national MPIs in Nigeria and Sri Lanka have included linked child MPIs with the same metrics as their national MPI, plus a child dimension, creating a superset of children who are both poor by the national MPI, but also poor by the child-augmented individual MPI. And if we look at other topics, and I would have wanted to go into this much more, Monica Pinilla, of course, is much the expert on disability, as we all know, and has done fantastic work, both this and more recent work, disaggregating global MPI for people living with disabilities and their households. And there's more work, I think, on the way. happily on this. We've done work on refugees, again with Fanny Koveshti. Corinne Mitchell has done other work on refugees, and looked at vulnerable populations and gendered analyses of them. We've done work geospatially merging environmental data with the PSUs of household survey data and looking at the joint analysis and also the methodological tripwires that happen when you do that kind of analysis with samples of different sample designs. And with Fanny Koveshti and other authors, we're looking at moderate MPI, seeing for the global MPI that doesn't matter at all for Colombia, many countries in Latin America, Arab states, and Europe. Can we create a superset? Nutrition is undernutrition plus obesity. Schooling goes up to 10 years for 12 years for children, 10 years for children. But there's a gendered aspect when it comes to years of schooling. Internet access, as well as electricity, flush toilets, drinking water piped into the house, these kinds of deprivations. And of course, James presented work on inequality, and there's other work on that going on. So that's just a very narrow ice skating across the top of a literature that many of the colleagues who are here in Bogota teaching this 2 weeks, and others who couldn't be with us, like Rizwan Al-Haq, who's co-authoring the gender work, have done. So thanks to all of them, and thanks to you, and I really look forward to Adriana's improvements, suggestions, overviews, and I do hope that there are research intersections with what you're doing in Universidad de los Andes. Thank you.
Thanks so much. ¿Ese celular de quién será? No. Okay, so we have 30 minutes, so I'm gonna go really fast through my presentation, and I'll open the floor for questions regarding the two presentations that we have, that they were very, very interesting, so we'll open maybe for 20 minutes. Okay, wait a second. It's not working? Yeah? Oh, espérame. Si quieres de acá, yo lo pongo. Okay. Okay, so I'm going to talk a little bit about multidimensional poverty and monetary poverty, not only in Colombia, but in the region in general, and try to link it with the presentations that we just had. So in terms of the multidimensional poverty, Colombia constructed and designed the MPI in the National Planning Department based on the methodology that we just heard from Alkire and Foster, not the one that they just presented right now, but the first one, and it transferred to the National Department of Statistics in 2012. They are the ones in charge of constructing the indicators and giving the information of poverty here in Colombia. I'm part of a committee of experts with Robert as well, and Yadira, and Monica. Many people here in this room are experts from a committee that the National Department of Statistics has to be able to do improvements and to look at challenges that the poverty measurements have in the country. So it's very interesting to hear new methodologies, new things, and to have you here for that precisely. Okay, so our multidimensional poverty index is characterized by 5 areas, and it has 15 indicators. The 5 areas are education, early childhood and for the youth, health, job conditions, and utilities and housing. If a household has a deprivation of in 33% of these indicators, they are considered as multidimensional poverty. I'm going to raise some questions about these conditions. This is as I told you, this is a methodology that is adapted from the global MPI that we just saw. But one of the questions are, how many indicators should we have on each of these kind of indicators? Like we should have 5 on utilities and housing and 2 on health, or these are questions that we need to raise in terms of the construction. How are we going to weight them? It's also important. Understand that poverty is not only, sometimes you would want to measure poverty, as we just heard, in terms of only females or only children, but this is a measurement that it's taking into account a household as a whole. So we have to take into account that the conditions that we are measuring there are for the whole household. We also want to know if they should be updated over time, like as I'm going to show you here in a graph. In Colombia, for example, in terms of multidimensional poverty, we have reduced in 10 years to half of the index. So it's important to find out if we need to update. For example, here we have 94% of the population has healthcare coverage. So is it that we want to have this type of indicator within my measurement of poverty or not? Or nobody, almost nobody, if you have a universal coverage, is deprived in that condition, for example. Do we want, given the use of technologies, do we want to have digital access as a new measure or indicator? Do we want to have banking access in this? So there are several questions that we want to make, and it's interesting always to have, of course, a global MPI just to be able to compare across countries, and not all the countries have the same type of development and the same type of context, but it's interesting to have the general one plus an adapted one, for example, to try to measure yourself in a better way. So this is the MPI for Colombia, and as I was telling you, it went from 2010, the red line is the national one, just look at that one, from 29.7 to 12.9 right now. So we start seeing that not very much, there's very few poor on these conditions or on these indicators. Well, if you look at monetary poverty, for example, in Colombia, almost from the same period of time, you will see that it has been going from an incidence of 40.8% to 39.3%. And also, an interesting thing, let's say, is what you can see, what happened during the pandemic. The poverty increased in urban, it was increased in urban areas and decreased in rural areas. And this was mainly, for example, for the emergency transfers that the government did in rural areas. That was proportionally to the income, which was much higher than what it was for rural areas. So it's interesting to see that different indicators move in a different way, and some of them are easier to move, let's say, over time than others, and are more sensible to some kind of conditions like the COVID pandemic, for example. So what we have here is what James was precisely saying. We have unidimensional versus multidimensional measures, and they're all interesting. It's not that one is better than the other. They are telling different things. If I think of a unidimensional condition as income, I would say that this is very unstable, let's say, in terms of a household. If a household has the same conditions, let's say today and tomorrow, but they lose their job, then they're going to be very differently in terms of monetary poverty, but they're going to be exactly the same in multidimensional poverty. So there are welfare indicators, and these welfare indicators, for example, in the monetary poverty, which is the P0, are individuals that are able to buy a basket of consumption. we have the P1 and P3, P2 and P3 that James already went through them. They have several properties as we saw them, but the value added that I think of this work is the inclusion of inequality. And I want to raise this as the biggest thing and important thing in terms of for Colombia and for the region, because look at this graph. Latin America and the Caribbean, I'm talking about Latin America and the Caribbean because we are here in Colombia, but you can see all the regions here. This is a graph of inequality across different regions in the world, and the highest inequality, you see it in Sub-Saharan Africa, then you see it in the Caribbean, and then you see it in Latin America. So having a poverty indicator precisely for our region that includes inequality in their measurement, in its measurement, it's very, very important, and it's a big deal, let's say, a big value added. And I'm gonna give more facts like this one in terms of inequality, which are gonna show you why this is very relevant for us. So despite that in the 2000s, the income inequality in Latin America has been going down, it's still very high. We have a Gini coefficient, so this is the Gini coefficient for the region, and it went in 1992 from 50.5, it increased to 52.8 in 2001, and it has been decreasing over time, but it has been stable for the last decade. So it's important. We're still a very unequal region, and it's still important to take into account this condition into our measurements, given the tie that we have in terms of poverty and inequality. Here, there's a graph that I took from the Human Development Report from the region that shows us how some countries progress more than others in reducing multidimensional poverty. And this might be the case given the type of indicator that they are constructing. But for example, if you see Haiti, which has a lot of poverty, it goes in 2012 until 2016 with a big decrease in multidimensional poverty, with the highest multidimensional poverty among the countries that we are looking at here. But for example, Honduras it decreased multidimensional poverty from, let's say, a little bit less than 30, so 38 to 20. And here we have Colombia, for example, in another period, 2010 to 2015. Okay. Regarding different indicators that we include within our measure of poverty, for example, if we were looking at how many households have, or how many individuals within the household have secondary schooling, you would see that the gaps would close. This is data as well for Latin America. So the gaps have been closing from the 2000 until 2018. Most of the black line is the bottom 20 percentile of the distribution of income, and the blue line is the top 20 percentile of income distribution. So the enrollment or the primary is very high, is much higher for the rich, and it has been increasing, and the gap has been reducing for the poor. But if we had an indicator like having tertiary education, of course, this is not going to be an indicator for measuring poverty, but it might be an indicator for measuring multidimensional, let's say, middle class, for example. We wouldn't see changes. And I would say something additional to this graph. If we would look at quality, for example, maybe all the graphs, including primary, would look like this. Yeah. So it would be interesting to see, and that's what, like the point I'm raising about which are the indicators that we are choosing and how are we measuring these indicators. It's very important in terms of what we're gonna get afterwards. And I just have this last slide, but I think I'm not gonna go through. These were innovations that we did in terms of measuring the MPI in Colombia. I just want to mention one, and is that we have been using, and maybe you can help us about this, and is that we have been using the administrative data to include several measures in terms of, for example, for the pandemic, we didn't know how to measure very well the attendance to school. It was a big challenge because this is, or for example, our access to health services. Many people would have coverage, but they would have not gone to health services because they were just full of people with COVID or in other conditions that you don't want to get there. So we used additional to the surveys, and the surveys were difficult to collect as well. They were not in presence, but they were virtual by phone. So one of the things we did was to use administrative data in order to check attendance to school, for example. Okay, so with this, I thank for the two presentations, and I open the floor for questions regarding the two presentations, please.
So thank you very much, Adriana, and thank you, Sabina and James, for this presentation. So now is the moment that we open the floor for questions. So if you can, please raise your hand, and I will pass the microphone. 1, 2, 3, and then we do another round.
Thank you. For Professor Sabina. Thanks for the presentation. And regarding child poverty measuring, it seems like a challenge for calculating due to the fact that information is reported by some surveys by household heads or parents, for example, which is problematic because we tend to leave behind the actual perspective of and the poverty experience of the children. So which alternatives do you believe exist for assessing this problem? And also if throughout your whole extensive work that you have presented to us, have you analyzed child poverty from this perspective? Thank you.
Thank you. I also have a question about how we can disaggregate MPA. So you said that it's not possible to disaggregate it by gender, for example, but what happens if I want to know or if I want to disaggregate it in intersectional view? For example, if I want to know what is the MPA for indigenous woman. So if you can tell me what is the best measure or the best method to do the task.
Okay. Professor Alkire, in some of the results that you shown, we can see that undernutrition affects almost equally to male and female. In contrast, when we look at deprivation in education, lack of education, we see that it affects more to girls than to boys. How do you explain this difference?
Okay, so maybe we answer and then we go for a second round.
Thanks so much. It's a very good question about whether data on children should come from a woman or a man in the household or the children themselves, and there are different data sets. So actually in our department in Oxford, there's Young Lives, which is a longitudinal study of children. It's not representative of countries, but it is representative of poor children with some descriptions. You have to look at the sample in Andhra Pradesh, India, in Peru, Vietnam, and Ethiopia. And that does include child responses, and it's longitudinal. It's been going since the 2000s. So it's quite a rich data set. There are also others. I was looking at one this week in India, which is entirely child reported. And so Again, like we spoke about earlier, one has to understand the frame of reference of the child, the perception of the child, and so the value of and the correct interpretation of those data, and the correct interpretation of objective data and how they might differ. And so I think it requires a lot more learning, but there is quite a large literature about that. There's a wonderful paper, what's his name? An Italian who's worked a lot on perceptions of children and the difference that it makes in measurement of capabilities, not necessarily in multidimensional poverty. So I think looking at that literature to understand the appropriate quantitative treatment and then using some of these data sources. The one I mentioned in India is a multi-country study, set of data that you can apply and receive the data. In terms of disaggregation for Indigenous, for example, as James presented, the MPI is subgroup consistent and can be disaggregated by any groups for which the data are representative. So Mexico, which was the first country to launch its MPI, also disaggregated it by Indigenous status from the very beginning, and has done so henceforth, and that made visible a significant inequality. Other countries have followed suit, whether it's Panama and different places, Ecuador. So I think in other countries by caste, the global MPI in 2021 with Fanny Covesti and Cecilia Calderon, we did ethnic disaggregations for 41 countries. And so you could see it wasn't always that there was a dispersion of poverty. There might be a majority ethnic group that actually was the poorest. So it wasn't necessarily small ethnic groups, but I think it's certainly a very useful angle. And then in terms of the gender disparities in the South Asian countries, that is a paper with Rizwan Al-Haq, which is about to be a working paper, but an earlier version of it with Abdul Alim is also online. So for nutrition, we cover 7 countries, not Afghanistan. And for child school attendance, we cover 8 countries. So these findings could change going global. And it was the case that in Bangladesh, more boys were out of school than girls. So there was a bit of gender disparity, but the numbers were, of course, far smaller. And the gap was far smaller in percentage point terms. So I think clearly in the other countries, there was reservations about sending the girl children to school, which were more cultural. But what was very positive is that earlier, a decade ago, the gender disparity in child nutrition was very strong. There was a boy-child preference, and the nutrition of girls was much worse. And so it was just such a celebration to see that that particular gender disparity has been overcome in these particular countries and data sets.
Thank you for your presentations. I have a question for Professor Foster and for Professor Sabina, and it's related to one of, I think, the key parameters of Multidimensional Poverty Index, and it's about the unit of analysis. And we also have talked about the importance of considering gender. For example, I estimate the multidimensional poverty in Peru for 2018, and I found no gender disparities in terms of incidence nor on intensity. And that was quite a surprising result. But then I thought about 3 reasons that maybe can explain that. And I want to know if you know other limitations that could be explained those results. First, the specification of questions. No, most household surveys do not actually have questions that are gender sensitive. For say, when you ask questions about labor, you mostly do not take into account, for example, the difference in household chores between women and men, the structure of the measure of the MPI. Some dimensions, you can argue that in some dimensions, women are probably more deprived than men, and that is also important to include those dimensions and eventually give them a higher weight in order to show those gender disparities or difference. And in the third place, the information that we have, the inter-household information, we don't always have information from each individual within the household. So that is also a limitation, and it's something that can explain this, in this case, the lack of gender disparity, significant gender disparity. Okay.
Thank you. My question, I don't know if it's a question, it goes to the last presenter. You asked a question in there that I think should be answered maybe before we leave this room. Something about the balancing of indicators across dimensions. Does it really matter so much? Because when I look at the global MPI, for example, the living standards has so many indicators compared to the other two dimensions. So what is the best practice? Should we look at balancing indicators across dimensions, especially when we are looking at equal weighting for the dimensions? What exactly is the best practice? Thank you.
Thank you. This is Ali Abdullah from Syria again. My question regarding MPI, what I understand, and please correct me if I'm wrong, it is try to answer who is the poor and how is they are poor. But is there any study to decide why they are poor? For example, if we go to the community and find that female going to the school less than male or boy, this is because culture, because demand on work. Is there any study? This is my first question. Second question is regarding security dimension. Is any country try to include security and safety dimension inside poverty MPI? Thank you.
Sabina, James, and Adriana, please go ahead.
Yes, well, yeah, let me think if I can get my head together here. Yes, when you have households, I mean, the issue is really difficult, as Sabina was saying before. You don't have the data gendered, and therefore you don't have a good concept of what's going on. There are data sources that are gendered. They're not particularly well suited for poverty, but they are perhaps better suited for indicators of women's empowerment. There is some movement on that way forward. The Women's Empowerment and Agriculture Index does time allocation studies, which are really crucial for understanding what's going on, and they do it across genders. So, or it has in the past done across genders. So you can get really great information as to what's going on in the household. And I find that to be just brilliant. But even the World Bank, after many years of trying to do MPI with gender and having infinite funds, didn't accomplish all that much, as far as I could tell. Maybe Sabina could tell something more. So I get what you're saying. There are some other, I'll let you say that instead of me. Yes, I will. One thing that I will say is that when you're trying to understand the poverty, it's always good to define what you mean by poverty first and then talk about what causes it second. And so to separate those two is really important, because the first one is different to the second one. But it's great once you've done the first one to then investigate the second. And of course, I encourage you to be doing that as much as possible on culture or other potential causes. The idea of the number of indicators affecting things, it certainly can. You saw my presentation, it was the number of indicators in that particular category of living standard, it having more indicators that led to the Shapley value being applied, giving the odd results. And it just happens. And it was an incredibly surprising outcome for me. I didn't expect that, but it did occur. So when you look at the number of indicators, one thing we've done, however, so that was unexpected. But one thing that we've done is we've made sure that the main dimensions have exactly the same weight. And therefore, the indicators have proportionally less weight when there are more of them. You can't imagine a more less biased approach to trying to ensure that what we really feel, that these dimensions are equally important, is preserved even when we are stuck with different numbers of indicators. I'll let Sabina, and there we go. Yeah, I'll let you go.
Thank you, and I do have a request for you. Please call me Sabina. So in terms of gender, just to build on to what James said, the Women's Empowerment in Agriculture Index was trying to obtain information from the primary woman and primary man of the household, and it was thought to be greatly more expensive. But if you think that the MPI kind of questions have a PSU size of 32 households, and that means enumerators will be there for a couple days. And so you change the chip so that they recognize the need to revisit households to obtain the other person who wasn't there when they did the first interview. Then the marginal cost of obtaining information for the woman and the man from the household goes down. And so that's an important idea. The DHS always usually get data from different members of the household. So I think there's one step is to change household data collection. I think another, as you said, is to get gendered indicators across employment, across health. Those are the two areas where it's most difficult. I think something I really appreciated in Colombia's MPI way back in 2011 was that there was an articulation that we want to use the household because we want our responses to poverty to encourage caring and sharing within the household. It's technically possible to do individual MPIs, and they do exist. Bhutan's Gross National Happiness Index that Soki Zamno co-authored is one of those. And there are also academic papers with many individual measures. But then there is a question about how to incentivize the caring and sharing, and how also, if I'm individual and somebody in my house is experiencing a disability or is undernourished or is out of school, then they're presumed not to affect me, but actually they do. And so there's something also that we lose by getting a beautiful gender measure. So that's why I want to use both together. Yeah, there's so much. But I think, yes, looking at missing data is something we are also now doing as we go into this gendered work to see how many it is and have algorithms to make that visible. In terms of the balancing of indicators, there's no rule, it's a ragged edge. Usually what we do is we look at what's possible, we look at the redundancy, and we try to be parsimonious to have the fewest indicators, each giving the most information possible. But there's also some technical things. If you think of Costa Rica's MPI, 5 dimensions, 20 indicators, equally weighted, the distribution is a step function. And there's some intricacies because if you have different weights, you have not a curve, but you have a little bit more complications. And so there's some benefits because when it comes to poverty cutoffs, they're very sharp cutoffs when all the weights are aligned. So I think looking into some of that is useful, but I think it's an area that's under-researched. And it would be interesting to go further. In terms of why, I think James answered, doing work alongside. In terms of security, yes, national MPIs have different questions for security. In El Salvador and in Chile, for example, experiences of crime and violence, their extent and their severity and impact are there. In Afghanistan, yes, the violence question is there, but they also have shocks, production shocks, income shocks. Because those also affect people very greatly in agricultural zones. And in Nigeria, again, there's violence and shocks in a dimension on unemployment and shocks. So they usually use a form of the violence and health questions, a standardized questionnaire form. You need to be careful when you look at violence to make sure you do not endanger the respondents. So far, no country or national MPI has used domestic violence because you need specially trained enumerators and it does increase the price. But technically it's feasible where there is data on domestic violence, but it's not, to my knowledge, I may be forgetting things in MPIs. But I think it is an area of great interest and a lot of experiences now with national MPIs analyzing that.
The piece of answer for you, for Peru, which is that it would be nice if you look at households which are monoparental and biparental, and if monoparental ones are females or males, and then you might find a difference, given that that's going to be interesting to do. And I think that's it. I think all the questions are answered, yeah. I don't know if we have some time, maybe just one last question, Monica? It's 5:31, I don't know.
So, the last round, and we go, I know it has been a long day. So
Just one, yeah.
last round, please.
Hello. One question, setting aside the measurement design of the index, more like the political use, the technical use of the data that comes out of this kind of index. Do you consider that in one country, in one same context, could be useful, or do you think it's coherent to have a household MPI along with an individual MPI that will focus more specifically, for example, in disability person, children, indigenous person, but how do you think that it could be useful or coherent at least to have a household MPI along with an individual MPI, and how could they both be complementary, or it could be different, not rationally to have in one government two different measurements, both with a multidimensional approach, but thinking on different ways of using them in terms of policy monitoring, or, for example, designing programs, targeting. How do you see if they both are coherent to have in one same country these two approaches, if they are complementary, or if not have no sense to have these two approaches in one same context?
Well, thank you. Talking about intra-household, like MPI, I was thinking if you have tested some measurements, talking about impact evaluation, in which you already detected the limitations that intra-household measurements has within the evaluation impact process.
Sorry, I didn't get that last one very clearly.
Yeah, like detecting the limitations that evaluation impact within intra-household measurements has.
The limitations of impact evaluation using MPI. And the last question. Running.
Thank you. My question was regarding the exhaustion of the MPIs in some contexts, particularly in the Colombian case for places such as Bogota, in which the MPI is so low that it seems that it's not providing any additional information. So my question was regarding which other maybe strategies have you find in the literature that other countries are using to adjust for this? For instance, thinking about subjective well-being being measured within the multidimensional poverty, or the quality of leisure time, or something like that. And also my question was regarding if maybe this could be also corrected by changing the way in which we're setting the deprivation lines. For instance, copying or adapting the 60% of the median income poverty line and use it to maybe the deprivation score distribution, to understand maybe if that could change the way in which we're measuring the MPI and it's valuable for particular contexts.
Okay, thank you. So the first question was saying, basically, let's say there's a national MPI, and then should we have another MPI for people with disabilities, and then another one for women, and one for men, and then one for youth, and then one for the older people, and then one for rural areas, because each of them have interesting particularities for their scenarios. And the problem that you rightly raised is that creates a management problem, and I'm guilty. So in Bhutan in 2015-16, we created a child MPI with a different dimensional structure and a different indicator than their national MPI. It took a lot of work, and it's never been used. Why? Because people, as Hansen and Herod put it, the binding constraint for people in decision-making is not information, but attention. They're busy. And if we give them 5 dimensions, 15 indicators, national MPI, 4 different dimensions, 17 indicators, child MPI, 3 dimensions, 12 indicators, rural MPI, they're going to choose. They're not going to use them all. So we advise a strategy that I mentioned briefly for children, which is to have the national MPI core. But then if you need to look at special aspects of indigenous life or of children or of gender, then you can create a superset, add dimensions or indicators specific to that individual group, recompute it so that if they were poor by the national MPI, their exact deprivation scores are the same with proportional weights and K cutoff. But then with these other indicators, we can also see the joint distribution of these, and any people who come into view as particularly deprived will be identified as poor. So it's a superset. Everybody who's poor by the national MPI plus them, and it's easier to manage. So I think I'll jump over to here and come back to you. But the other way of creating a superset is that may be relevant in Bogota is rather than adding indicators, though the indicators that are often added have to do with relationships, social isolation and loneliness, or other aspects of well-being, environment, lived condition, etc. You can create a superset by having more stringent deprivation cutoffs. So you mentioned quality. So instead of employment, is the employment meaningful? Is it decent by some kind of operational definition of ILO? What is so other aspects of decent work you could put into that, other aspects of quality you could build into others. And so again, everybody who is poor would be poor by this, but there would be a superset of additional people who didn't have the extra quality that's required in the Bogota MPI, and you could make them visible. So that's another way of augmenting the MPI around a core measure, which has legibility and recognition, familiarity. And finally, coming back to intra-household, that's tough. So we're getting down to brass tacks of sample design and data. In the Maldives, poverty is very low. Deprivations are very low. Households are small. We had to count our number of unweighted sample, and we use the DHS rule. If it's less than 25, don't report it. 25 to 50, bracket it. Always, always, always report standard errors, and hope that your audience understands standard errors, confidence intervals. But you also, as we mentioned earlier, have to look at the missing. Because if you're systematically missing people who are working when the interviews are taking place, or who are migrants in other spaces, seasonal migrants, then you'll have biased results. And so you have to be very careful. And I think we need to work with demographers and sample specialists to do a lot more better work on that. We are just basically rolling out a crude technique. Again, first generation work will get a lot of criticism, but hopefully it'll get better because of that.
Well, thanks so much for all your questions. Thanks so much for having both of you here, Sabine and James. It's very nice to have you here. It's an honor again, and hope you enjoy all the classes and a great conversation we had here. Thank you so much. Bye-bye.
Thank you very much, everyone. For those in the summer school, please